Okay. Hello everyone. I hope I am audible now. Yeah, one of you can confirm by replying.
Yes, sir.
Okay. So let's start solving a paper. This paper is shared with you. I guess all of you must have received it. I'll keep it open like this over here on the left hand side, and we will be attempting this 3 hours paper. Mostly we'll be attempting numericals. So let us start. So you all can also take your books out. Don't just listen. You have to solve with me. Then only this lecture will be useful to you. Okay. So please start solving along with me. It's the old syllabus. So many things might be out of context based on current syllabus, but still, most of it, 90% of it is same. Yeah. So let us see the first question. I hope you can see the paper. The first question says that, I mean, the marks also will be quite different than that. This is May 2014 paper, so the marking scheme is slightly different over here. But don't worry, we are solving the numericals mostly. So we need to convert the given circuit into a single current source in parallel with a single resistance between point A and B. Alright. So what are they asking us to do? Let me reframe it over here. They are asking us to do the following. They want us to convert this entire circuit between A and B into one current source, possibly in this direction, in parallel with a single resistance, like this. This is what they want. Okay, A and B. Now we need to find the value of this resistance and the value of this current source. Alright, so you all with me? Let us begin. Okay, so let us draw this quickly. 4 ohm, then we have a 8-volt battery over here, and this is my A and this is my B. This is 10 volt, 5 ohm, 4 ohm, and 8 volt. Okay, so let me know how will you solve this further.
Sir, voltage transformation, sir.
Yeah, correct. So probably we are going to be transforming this voltage source in parallel with in series with a resistance into current source, right? So this current source will come, parallel resistance will come. What is the value of this resistance? 5 ohm only. What is the value of the current source? This 10 volt divided by 5 ohm. Okay, the value of the current source is 10 volt divided by 5 ohm. That will be 2 amperes. I hope I am right. All right, so this is what we have done. A, B, you all can also solve it simultaneously, please. If you have any query at any point of time, please interrupt me. I'll explain it again. All right, any query here? Okay, next, I mean, what we did, we should, I mean, we can say source transformation, but is understood. Next, we'll apply source transformation over here. This 8-volt source in series with a 4 ohm resistance will be converted into a current source and a parallel resistance. How do we determine the direction of the current? The current will go from negative to positive. from the battery. So that's why we have done the arrow upwards. So this is 4 ohm. How do you calculate the current? This voltage 8 volt divided by 4 ohm. Okay. So it's 8 volt divided by 4 ohm, which is 2 amperes. Alright. So this is the earlier circuit. This is 2 amperes and this is 5 ohm, and this is A and B. Now, now tell me, what do we do next? Can we add this 2 ampere and 2 ampere current source? Yes or no? 2
Yes,
ampere
sir.
parallel to 2 ampere current source will add up, okay, and they will become 4 ampere. So this will become like this. um, Let me rub it out. Yeah, y'all can also draw it at your end. This will be the current source, 4 ampere. And what about the resistance? Are resistance 5 ohm and 4 ohm in parallel? Are they in parallel?
Yes, sir.
Yeah. So here we write 4 ohm parallel to 5 ohm. Alright. So 4 ohm parallel to 5 ohm, what will be the answer? Quickly tell me. It will be,
2.22.
okay, just in case if anyone have forgotten, this is the way we do it, and it's 2.22. So finally here we can write it 2.22 ohm. And I think that is what they want. That is what they were asking. Convert the given circuit into a single current source in parallel with a single resistance between point A and B. So this is your answer. Okay. And typically according to the current marking scheme, if this is asked in the exam, this will be asked for 5 marks. Okay. And for 5 marks you should not spend more than 10 minutes. Okay. So for 5 marks spend less than 10 minutes. And we have started at around 402, 403, and there is just 7 minutes past. So we are going good. All right. Anyone has any query?
No, sir.
All right. So let us go to the next numerical. I hope the question paper is visible to you on the left and on the right hand side of the screen.
Yes,
This
it's visible, sir.
okay. So now uh, we are going to take up next question, question number 1b. All right. So we have to find the voltage VAB using superposition theorem. Okay. So it will be a revision of superposition theorem. So what we have to find out? VAB question mark. And which theorem is given to you? Superposition theorem. Okay. So quickly draw the circuit diagram. So we have been given 6 volt over here, then 5 ampere. Here we have 5 ohm resistance. This is 10 volt. Okay, and this is A and this is B. A and B, and this is 6 volt. All right. So what do you mean by superposition theorem? Anyone wants to go? I mean, how do we solve it using superposition theorem? So there are three sources: 6-volt source, 10-volt source, and a 5 ampere current source, right? So we first consider, let's say, 6 volts voltage source. Okay, so when we consider 6 volts voltage source alone, what do we do with the other sources? Other sources will be deactivated. Meaning, if it is a current source, replace it by open circuit. If it is a voltage source, replace it by a short circuit. So let me redraw the circuit. Alright, this will be open circuited and this will be short circuited. Okay, so tell me what will be the value of VAB over here. Let me call it VAB dash. Anyone? What will be VAB? See, this point is connected to this point. So actually this point is as good as B only. Okay, right? And VAB, the parallel voltage connected to VAB is how much? 6 volt. So how much is VAB? VAB dash, anyone? Yeah, you have to speak up because it should not be a one way. I should know that you all are solving it actually. VAB dash, how much it should be? VAB,
6 volt.
yes, it will be 6 volt because it will is the parallel voltage. A point is over here and B point is over here and it is connected in parallel. So it is indeed 6 volt. Yeah, correct. So we have considered 6 volts voltage source alone. Next we will consider um, let's consider 5 ampere current source. 5 ampere current source alone. So what happens to the other independent circuits? Voltage source will become short circuit. So here this becomes a short circuit. Then we have 5 ohms resistance. Then this also becomes a short circuit. We have a 5 ampere. Now tell me what is VAB? Yeah, quickly. I mean, we have to.
So 5 into 5, I guess.
No,
25.
no. See, what happens is, see, listen carefully. Why it is wrong? It's okay, fine. This short circuit is in parallel with a current source. So anything parallel with a current source, this will deactivate it. I mean, this will become redundant. Okay. So if you have a, let's say this is like a scenario like this, right? This is 5 milliampere and you have a short circuit. So what will happen to this current source? It becomes redundant, right? It becomes redundant. The current flows through this. This is a short circuit current. So this current will be more. Are you following what I'm saying? Those who were saying,
Yes, yes.
I mean, if 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 this short circuit was not there, then VAB is 5 ampere into 5 ohms. Then it is correct. This short circuit is not there. If this is not there, okay. But since this short circuit is connected, this means it will follow short circuit only, not this. So this becomes redundant. Okay. So what is VAB now? This becomes redundant. No current is flowing. This is also short circuit, right? So it is as good as, let me redraw it. The circuit is as good as this. Now tell me what is VAB, because 5 ohm also in parallel with a short becomes a short. VAB how much? 0 volt. Is this clear to you? Yeah, everyone?
Yes, sir.
Alright. So let's move on. There is one more source, 10 volt voltage source. Let's consider. So C part is 10 volts voltage source. So look at the diagram on the right hand side of this paper. 10 volts voltage source alone. So we have to be very very patient by solving this paper. I mean any paper in your upcoming exams also. Be calm all the time. 10 volts voltage source, that means other sources should be short circuited. So 6 volts voltage source will be short circuit. This 5 ampere current source will be open circuit. Then we have a short. Then we have this 5 ohm, and then we have this 10 volt. Okay, now can you tell me how much is the voltage? VAB, I mean we call it VAB triple dash. Anyone can tell me? Based on the discussions we had so far, anything parallel to short goes. How much is the voltage?
Sir, 10.
Yes. How? Because this 5 ohm parallel with a short becomes a short only. Okay, and then at the end this is open circuit, right? So the scenario becomes like this: A, B, and 10 volts. So VAB is 10 volt. Now, as per superposition theorem, you need to write this statement as per or according to superposition theorem. We need to add all the voltages, or if there are currents, we need to add the currents. So what is VAB? Please write it down in your notebooks also. It's VAB dash plus VAB double dash plus VAB triple dash. What is VAB dash? 6 volt. VAB double dash is 0 volt and VAB triple dash is 10 volt. So 6 plus 0 plus 10, that is around 16, and that is the answer. Understood how superposition theorem works, everyone? And the concept of parallel, short, anything with a short circuit becomes redundant. All right, everyone.
Yes, sir.
Okay. Now let's move on to the next numerical. So next numerical is from AC circuits. Okay. Let me save it. Yeah. Let's move on now. Question number 1C. So we need to find the average value of the following waveform. So this is the waveform given to me. I'll redraw it once. This is time in seconds, and the waveform looks something like this. Okay, this is 1, this is 2, and this is 4 volt. Okay, height is 4 volt, and this is voltage. So tell me, how do you find the average value? I hope you all have not forgotten.
Sir, the formula is area under the curve upon base something.
Exactly. So area under the curve, we have to first find the equation for this V of t, right? So first of all, tell me what will be the time period. The time period is something which repeats
1 second.
itself. Yeah, so this is t. So t is 1 second. And just write down for a, I mean, just for confirmation, the average formula is area under the curve. I mean, this is the formula for area under the curve, 0 to 1 v of, I mean, v of dt or v of t dt. It's one and the same. Now we have to find the equation of this. Okay, so let me help me out in doing that. So from 0 to t, from 0 to 1, if t goes from 0 to 1, what is the voltage increasing at a constant slope, right? So voltage is increasing at a constant slope of 4 volt per second. So can you tell me what will be the expression of V? Yeah, what will be the expression of V? See, let's consider this as, let me just reframe it over here. Let's consider this as a Y and this as X. So what is the formula? Y is equal to mx, right? Plus C, right? Correct or no? So
Yes,
what
sir.
is m? M is the slope. So they are saying ki, I mean, the slope is 4 volt. And what is X here? T. So what is the form? And what is V over here? Y. So tell me what is V now? Slope, that is 4, into x, that is t. There is no intercept. It's passing from 0. So the equation of V is 4t. Did you understand this?
Yes.
Okay. So this is 4t. Now this we are going to substitute over here. Okay. So write it along with me. V average will be 1 upon 1, 0 to 1, 4t dt. Okay. I mean, here it is V of t only. Now what is integrals? I mean, we can take 4 out. What is integral of t dt?
T square by 2.
Yes, t square by 2, t going from 0 to 1. And now just a formality, 4 into 1 square upon 2 minus 0 square upon 2, which is coming out to be 4 into half, which is 2 volt. Yeah, please complete it. Should not spend more than, I mean, this is also asked for 5 marks, and we have taken less time. You should devote less than 10 minutes for 5 marks. Okay. The second numerical also was for 5 marks, and we have taken a little more time because it was based on question answer. Like I was asking you all questions based on the concepts, but still, you should keep a track of the time. Because all this will, the timing will come when you practice more and more. The only way to study EEE is practice. Can we move on to the next one now? Hello?
Yes, sir. Yes, sir.
Yeah. If you're not speaking, then you can mute yourself. 1D, question 1D. Okay. Let us go to the question now. I have to expand it. Okay. Let us carefully read the question. For a series RLC circuit having R value 10 ohm, L value 0.01 Henry, C value 100 microfarad, find the resonant frequency, quality factor, and the bandwidth. So it's a straightforward. If you all have studied this AC circuits, you might have known that series RLC circuit. If you have encountered, is a simple matter of solving by given formula. Okay, so I will help you out in this. First, write down the data. So we have you all can write it along with me. You have a series RLC circuit. See, series, parallel RLC, series resonance, parallel resonance. These are important things. So we have a series RLC circuit where R value is given as 10 ohm, L value is how much? 0.01 Henry, and C is 100 microfarad. So this is the given data to us. And what we need to find out? Resonant frequency. So resonant frequency is denoted by Fr. If you want to calculate resonant frequency in hertz, then Fr, or we can also calculate in omega r. Okay. Then what we need to find out next? Quality factor denoted by capital Q. And then we need to find the bandwidth. Bandwidth is denoted by BW. So all these things we have to find out. Alright. So let us start with our discussion. AC circuit is an important topic, and so if you have not yet started, please start taking it. Little more practice. Okay, so in a series RLC circuit, the formula for resonance is given by, I told you it's just a matter of remembering the correct formula, right, in the correct situation. So resonant frequency is given by 1 upon 2 pi square root of LC. So if you want to calculate omega r, it is 1 upon square root of LC. Okay, this I am just in case if someone wants to calculate. Okay, so I'll substitute the values over here. Do not directly write the answer. Please substitute in one step and show it. So L is 0.01 into 100 into 10 raised to minus 6. So please calculate and let me know the answer. Anyone with the answer? See, I am not here to provide the answers. I am here to, discuss the strategy how to solve.
Yes, sir. 1 minute.
Yeah, yeah, yeah. You can take your time, no problem. But remember, we are solving a ESC paper, so time is also important.
159.235.
Yeah, that's correct. 159.23. I was getting around 1.5, but plus or minus 5% is allowed. So this is the answer close to it you should get.
Yes, sir. It's 2 3.
Yeah, fine, that's fine. 2.3 is also correct. Next is we should calculate quality factor. Now quality factor is given by the formula for a series RLC circuit. Is a series RLC resonance circuit, okay? So these are some standard formulas. 1 upon R L by C. So please calculate this. Please substitute over here the values and let me know the answer. I'll wait. Only thing is you have to, you know, work with your calculator very well. You cannot make a mistake over here because it will cost you dear marks. Yeah, anyone? The quality factor Q value is?
Is it 1?
Yes, it is 1. Normally the value of q is less than 100, or and most of the cases is less than 10. So 1 is correct answer. Then the bandwidth is given by the formula. It's a formula driven numerical, r divided by 2 pi l. Alright, so r is 10, 2 pi l is 0.01. So please calculate this. 0.01. Bandwidth will be closer to your resonant frequency, nearby.
159.235.
Okay, similar to this you are getting, right?
Yes, sir.
Yeah, it's correct. So again, if they ask you in the exam, this will come for 5 marks, and this should not take less than, I mean, not more than 10 minutes. Okay. Okay, fine. Now let's move on to the next one. I told you the paper pattern is different because it's quite a old paper. Don't worry about it. We are here to solve the numerical and everything else. Okay. Next is draw the phasor diagram of three-phase star-connected load with a leading power factor. Indicate line, phase voltage and currents. Now this topic I have covered in the class, but yet I mean since it is asked for 2 marks, but I mean believe me, if it comes in the exam now, it will be asked for minimum 5 marks. Okay, no question is lesser than 5 marks will be asked mostly. So this phasor diagram, if you all want, I will draw it, no problem at all. But at the end, you all want me to draw it or consider it once, or you all can manage on your own. Hello.
Sir, you can just go through it at least once.
Yeah. I will go through it. So we have to draw the phasor diagram for a three-phase star connected load, and we have connected with a leading power factor. Okay. Now I guess we have solved a numerical. I mean, we have solved this topic actually in the live in the class, but since you all are telling me to just go through it once, can anyone help me out? Can you check in LMS in which lecture number this topic was covered, so that I can remove that or open that particular topic directly? Just check in your LMS which lecture it was covered. I have written normally the topics, I write it in the LMS. Just let me know. I've definitely covered this topic.
Lecture 41.
Okay, 41. Phasor diagram. Okay, okay. Let me open and check. Lecture number 41. I don't know about which part it is, but let me check and cross check it. There are some numericals which I have solved, but this is not there. So not in 41A.
Sir, phasor representation, if we are talking about that, then that lecture was lecture number 31, because there it is written phasor representation rectangular and polar form.
No, 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 no. Phasor diagram is different.
Okay. We're talking phasor diagram. Okay. Okay.
Yeah, yeah. Phasor diagram is different. This is the phasor diagram for three phase. This is the one. But what they have given, let me cross check. Phasor diagram for three phase star connected load. This is a star connected load. Yeah, for a three phase star connected load using two wattmeter method, this is also true. So what you want me to do, you want me to solve this right now? I mean, show it how it's done once. That is what you're asking. Hello.
Yes, sir.
Okay. So just hold on. You all can note it down. Can this also be the, I mean, this also can be the possible solution. Okay, let me check. It's E. Okay, I guess for a three phase star connected system, we have covered that topic. I am also checking in the LMS. In the three phase circuits. Yeah, lecture number 40. Let me check lecture number 40. This also true, this can be done, but this is much simpler. This is using two wattmeter method. If they ask you draw the phasor diagram of the star connected load using two wattmeter method, then this is the one. Let me show you lecture number 40 contains ones. Okay, here also we have A and B. So probably here I might have covered. Yeah, this is the starting point. See, in a brief, I'll let you know. In a three phase system, there are three phases R, Y, and B. Now, in phase wise, each of them differ with each other with 120-degree phase shift. Okay? Then, star connected system. Yeah, this is the phasor diagram. So, this is what you want to, I mean, want me to draw, right? And explain how it has been drawn. Am I correct? Hello?
Yes, sir.
Okay. Alright. So, this can be done. This is not so hard at all. Okay, let me keep it here as it is. and let's try to draw it. I'll not show the complete thing, but I'll at least get you head started how it has been done. So for this you have to understand something, this diagram. Now this is a three phase star connected system RYB, and this is star 1 2 3. Each leg is having an impedance Z phase, Z phase, Z phase. Okay. Now there are certain phase voltages. So this R and N is the neutral, VRN, VBN and VYN are the three phase voltages. Okay. Now there are line voltages also. Line voltages means between R, Y and B. So VRY, VBR and VYB. Now you will say not VRB. Okay, this is RYB. So you should remember the sequence like this. You should always remember R, Y, B. So VRY, then next is VYB, and next is VBR, not RB. Are you following? So these are the three line voltages. Is this clear to you?
Yes, sir.
Okay. So these are the things we should remember, and also this you need to figure out that how we have written the three line voltages. All right, each of them differ by 120 degree, so we have written VRN, VYN and VBN are the, I mean, are differentiated by 120 degree angle, as you can see over here. Also, these are the three line voltages. Now for a balanced system, all of them are equal, okay, in magnitude, but they differ from each other. Now let's see how they differ from each other. So we are writing phase voltages in terms of line voltages in terms of phase voltages. Okay, so phase voltages are measured with respect to neutral. So how many phases are there? R, Y, B. So we have VRN, VYN and VBN. Okay, so phase voltages we are we are finding out the line voltages in terms of phase voltages. So we are writing how much is VRY in vector form. Okay, so what is VRY? VRY is VRN plus VNY. Now how this has come, you have understood how this has come. See, I'll help you out. So this is nothing but VRN with respect to neutral minus VYN. Have you understood this much? N is the neutral common, so ultimately it will be VRY. Is this understood? Yeah.
Yes, sir.
So this we can write it as VRN. If you want to write it as VNY, it will be plus VNY. Okay, and then you do some polar to rectangular, rectangular to polar, and finally you get this. I mean, this is something different, but this is the equation which you remember. VRY is VRN plus VNY. Similarly, VYB is VYN plus VNB. VBR is VBN plus VNR. Okay, so this we should remember. Okay, and yeah, then we are ready to draw. I mean, we will be ready to, just start. How to start? First of all, write down the relations, this relations. So kindly write it down in your books. I mean, this will take a special extra time because we are considering, in detailed diagram, but it's fine, I'll help you out in it. This is for star connected load, remember. Similarly, we have a delta connected load also. All right, just a sec. Okay, so what are the things you will write? You will write V R Y. VRY is line voltage in terms of phase voltage. I showed you how we got that. VYB is VYN plus VNB. Somehow you have to remember it. VBR is Okay, and these are line voltages. Okay, so these are line voltages. Is that clear to you?
Yes, sir.
Yeah, and let's say that we assume a inductive load. Let's say for the sake case we assume a inductive load. So if we are assuming an inductive load, what will be the three phase currents? IR, IY and IB. Alright, so you can write this also down. Okay, and in the next time summary, what we can do is, in case of a star connected, this thing, your line current and phase current are same, but your line voltage and phase voltages are different, huh? So line current and phase current is same. So this is same as your line current or line. This is same as line or phase current. They are same. All right. Now let us see how to draw this. Okay. Let me take a blank screen. Okay. Okay. Fine. So first of all, you are listening to me. Please
Yes, sir.
concentrate over here. Remember over here, these are the three phase voltages V, R, Y and B. The phase difference between them is 120 degree. Remember that. So what will be your starting point? Your starting point will be drawing line voltages. Also the phase difference between them will be mostly how much? You cannot determine line voltages phase difference between them right now. You know the phase voltage. The phase voltages are. Can you tell me what will be the phase voltages? The three phase voltages. VRN, then V. Tell me. VRN, VYN, RYB, na, and next is VBN.
BBM.
So these are the three phase voltages. So first of all we have to draw them. Okay. So let me take some color, black color, to represent phase voltages. So phase voltages I'll draw it like this. Don't draw it straight line, draw it a little bend. I'll explain you how. Yeah, like this. So I have written here VRN. Why start with R? R, Y, B is the phase. So go by this sequence R, Y, B. Okay. So Y, V, R, N. Next, what will you draw? V, Y. If you take a scale, if you have a protractor, you have a protractor, right? So take 120 degrees from here and draw another line as. Let me redraw it. Take 120 degree from here. I am drawing it approximately. So this will be VYB. Are you understanding? And another 120. I mean this angle is 120 degree. I hope you are following. Yes or no?
Yes,
And
sir.
again 120 degree you take it and you draw what? VBN. I hope it is clear now.
So shouldn't that be VYN?
V. Acha, while writing I
The
have wrote. Okay,
VYB.
okay, okay. While writing I wrote this. It should be VYN only and VBN. Is this thing clear to you? This much is clear to you? So all of them will have a phase difference of 120 degree. Easy so far? Yes or no?
Yes, sir.
Okay. Now, we are finalizing it now. Now, what we need to do is draw mirror images. Now, how to draw mirror images? I'll explain. Mirror images, I'll draw it with, let's say, dotted line and this color. What is the mirror image of V, Y, N? I'll draw with dotted line. V, Y, N ka mirror image is what? V, N, Y, right? Yes or no?
Yes, sir.
So same magnitude, draw V, N, Y. What is the mirror image of VB and VNB? So same parallel line, same extended on that side. VNB. And what is the mirror image of VRN? VNR.
VNR.
VNR bar. You have drawn this? Have you drawn this? Can I move ahead?
Yes, sir.
Okay. Now only listen to this. What is this? Relation between line voltages and phase voltages. How they are related, right? In vector form. So identify where is VRN. This is VRN. And what is VNY? VNY. Now, do you remember when you add two vectors according to the law of parallelogram, how you should add it? Like this, right? This will be the resultant, right? Yes or no? Parallelogram, na? This becomes
Yes.
parallelogram. Are you understanding? So this is called as V R Y. So this red color is my line voltage. Are you understanding? Yes or no? Did you
Yes, sir.
did you understand this? How to draw? Okay, very good. Now next is identify VYN. VYN is over here and VNB. VNB is over here. So where will the parallelogram come? Where will the line come? Line voltage now? Exactly in the middle of this. Yes? So again draw it. Dotted line and dotted line. So this is a vector sum, right? This is a vector sum. This is V, Y, B. Again a line voltage. The red color are the line voltages. And the last one is VBR is the addition of VBN. VBN, this is VBN and this is VNR. So exactly in the middle. I hope this is clear to you. This is by the law of parallelogram. This is VBR. Easy it is. If I minimize this, this looks like this. It's not yet over. Huh? Let me know when you have completed drawing. This much.
Done, sir.
Okay, great. Now they have given what? Inductive load. So in an inductive load, tell me the current is leading the voltage or lagging the voltage?
Current is lagging.
Current is lagging behind the voltage, right? So in an inductive load, current I always lags behind voltage V. Now, which current and which voltage and which current we are talking about? We are talking about phase voltage and phase current. All right. So, if it is an inductive load, the current will lag. That is how we have drawn the diagram over here. See here. See, once you have drawn this, draw green color once. Okay. VRN. VRN is the phase voltage. So draw IR bar behind it. Draw IB behind VBN and draw IY behind VYN. Simple. But in our case, what is given in the paper? What is given to us? Leading power factor, right? This is lagging power factor. This is called as lagging power factor. So leading power factor, how will you draw? Can anyone give me a hint? This is lagging. This is lagging, but we have to draw leading.
Will represent current after the voltage factor.
Exactly, we will represent the current after the voltages. So let me draw. Take green line. See here. So we'll represent the voltage over here, current over here. This will be IR. Understanding why I'm what I'm saying? This is
Yes, sir.
IB and this is IY. Okay, and the phase angle phi is between the phase current and the phase voltage. So this is phi. This is phi. Let me show it to you. VBN is the phase voltage. This is phi, and this is phi. Phase voltage is always between. This phase angle is always between phase voltage and phase current. Okay. So this is the diagram for a. Sorry. This is the diagram for a leading power factor. Okay, for a leading power factor, your phase current leads corresponding phase voltage. The phasor diagram is very simple. You'll have by now you must have understood also, right? Agree?
Yes, sir.
This is the complete diagram if you want to see. Okay, and they have written in the numerical in the paper that highlight line current, line voltages, phase voltages, and currents. So phase voltages, what are the phase voltages? Let me write it over here. Can you help me out? What are the three phase voltages? VRN, VYN, and VBN, RYB. And which are the three line voltages? Can anyone tell me? The red one, VRY,
RY.
VYB, and VBR.
PVR.
And which are the line current and the phase current are the same. So let's say I am writing phase current. So what are the three phase currents?
IB,
IB,
IR,
IR, IY.
IB, and IY. Yeah. So this is for a three phase star connected load or a three phase star connected system. Easy it is, actually. Three phase systems are very easy if you follow it systematically. So this is the diagram. This is should be your answer. And they have asked for 5 marks in the exam, but you can solve it within 10 minutes, but we have taken around 15 minutes time because I have explained you everything. So this should also take around 10 minutes time. I hope it is clear now. You have understood. Similarly, delta connected load also is similar. Okay, not so hard. So there now, what will happen is instead of voltages, we'll draw currents. That's the difference. That's it. Here we are drawing voltages now in delta connected load. I've already said the notes. You can refer it. Is that okay,
okay,
everyone?
sir.
Yeah. So now we'll take a 2-minute break. Let me also drink some water. You all can also take some break, 2-minute break, and then we'll resume back. Okay?
So, can I ask one question?
Yeah, you can ask.
So in exam, we have to take the angles accurately, or we can just.
No, I have the way I have done it. It's fine.
Okay,
If
okay,
you
sir.
want accurate, then better you take a graph paper and do it properly, 120-degree and all. Then it will come exactly proper. Now, one more thing I wanted to add. I have not marked one thing. Normally, they expect that the phase voltage, the phase angle. I'll show you. Wait. They expect this also. VBN and VBR, the phase angle is 30 degree. The difference between them is 30 degree. This I have not written, but here if I want to add now, I can add one more thing. Where is the pen now? Yeah. This. angle, this angle which I am marking, VB, VRY, let's say 1, we'll consider this one case, okay? This angle should be 30 degree, okay? Are you following?
Yes, yes.
Yeah. So this is for leading power factor. And you know what is the angle between VRN and VNY? 60 degree. This angle, 60 degree. Okay? And what is the angle between VRN and VBN? 120 degree. So if you go by a protractor and all, then you will get a perfect thing. But approximate is fine. I mean, if you're at the end, you cannot use colors in the exam. You can also you can only use a pencil and a pen, that to blue or a black, right? So in that case, by pencil you can draw the other things, and at the end, line voltages you can draw with pen, so that you can distinguish. Is that clear what I'm saying?
Yes, sir.
Okay. Don't use red color and all, right? It's not allowed. Only blue pen or black pen is allowed in the exam. So, okay, fine. So, this was it. Uh, 2 minutes break is also utilized. Okay. Next question is, now you see this is a numerical based on transformer. Now, numerical based on transformer, good news is it's not there for y'all. For your syllabus is not there. Not in current syllabus. So what you have in current syllabus, the theory related to transformer, which I am going to record and share it with you all, right? So you do that much theory and that's it. Okay? Is that fine, everyone?
Yes, sir.
So now we'll go to question number 1F. I mean, we have written that not in current syllabus. You don't have a numerical. Then question number 1G. See, theory question here I am going to tell you how much the split up marks are. To draw the circuit diagram and input output waveform for a full wave bridge rectifier, right? So we have a full wave bridge rectifier. And they if they ask you in the exam, this will be for 5 marks. So how will you get your 5 marks? It is as follows. Circuit diagram, first of all, will carry 2 marks. Then you have input output waveform. Oh, input and output waveform, right? So input and output waveform together. So in this case, the circuit diagram will be 2.5, and input output waveform will be 2.5. I mean, it depends upon the examiner how much they are giving priority. Some examiners might give you this as 3, this as 2. Okay, but you don't worry, the marking scheme for all the examiners will be same for your end semester exam. Okay, so it's not that some examiners will give you 2.5, 2.5, others will give you 3 and 2. Not like this, it will be uniform marking scheme. But this is generally I am telling you, and this is the way we give the marking scheme. So if you draw the correct circuit diagram of a full wave bridge rectifier, you will get around 3 marks, and input output waveform 1 marks each. Is that clear to you? I hope you remember, you have not forgotten how the waveform looks like, right? The input output waveforms. Let me just jog your memories around. So let's say this is the input. How will be the output waveform? Anyone can tell me of a bridge rectifier? Like this, right? So that's it. The green one is the output, V out, and the red one is the input. So this gives you 2 marks. As simple as it gets. This is time and this is voltage. Are you understanding? Similarly, if you draw the diagram, you will get your particular marks. Any doubts in any, I mean, anything else? If you want to ask, you can ask now. How much to write, what not to write, you can ask. Or else I'll proceed. Hello?
So let's proceed, sir.
Okay. Okay. So we'll come to 2A. Now, from your side, question number one will carry, you know the pattern, right? Paper pattern. It will have a lot of options in your end semester exam, right? So from question number two onwards, you will have a lot of options as it follows the particular pattern, right? In all the papers, you must have got the pattern by now. So next we'll be solving a DC network theorem. So let me keep it a little small. Yeah. So find the current through 4 ohm resistance using nodal analysis. So let's start, writing it down. So current through 4 ohm resistance, and we have to solve it using nodal analysis only. And if you are if they are asking you to solve it with nodal analysis, and if you are solving by mesh analysis, you will not get any marks because the method is written. You have to follow that method. All right. So stick to the technique. If you don't know a particular question, then you can go for an option question. Okay. But see to it that DC network was done, with a lot of practice. So you must have already practiced a lot of numericals by now. So yeah. So let's start. Let's do it together. So draw the circuit diagram in your books. Oh. It's important to draw the circuit diagram in case of DC network theorems or DC circuits. This is 6 volt, 3 ohm, 6 ohm, 2 ohm, 4 ohm, and they have marked the nodes also, A and B, and this is 5 amperes current source. Okay, let me maximize it because now we are going to solve it using nodal analysis. Can we start? Are you all ready?
Yes, sir.
Okay. So nodal analysis mean that you have one node and you have one reference node. So this is my reference node. Okay. And you mark all mostly as outgoing currents. So let us say this is I1 outgoing current, this is I2 outgoing current, this is I3. I3 is also going into node B, then this is also outgoing, let's say I4, and this is incoming. It is by default a current source, right? So yeah, so let's start applying KCL. You have to apply KCL or KVL? KCL, right? In a node. So yeah, we have to apply KCL. So we'll apply KCL at node A. Can you tell me what is a KCL at node A? All are outgoing currents. So can we write I1 plus I2 plus I3 is equal to 0? Everyone understood how what we have done? Yes?
Yes, sir.
Okay. So this voltage at node A we call it VA, and voltage at node B we call it VB. Okay, so remember that this voltage we call it VB, and this voltage we call it VA. So now I1 will be VA minus 6 upon 3. I1 is VA minus 6 upon the resistance 3. I mean current is voltage upon resistance, right? Then I2. Can you tell me what is I2? Anyone?
VA minus 0 upon 6.
VA minus 0 upon 6. Perfectly said. I3.
VA minus VB upon 4.
VA minus VB upon 4. Yes, absolutely correct. Now do not do LCM. Okay, I recommend do not do LCM at all. Directly you can solve it. Alright, so I'll tell you how. What is VA upon 3? 0.33. You can check it out. VA minus 2 plus 1 upon 6 is how much? 0.166. Be it in decimals, no problem. 1 upon 4 is 0.25. So 0.25 VA minus 0.25 VB is equal to 0. So far so good. Now add all the VA terms together. So what do we get? It's, if you add them together, 0.75 close to VA minus 0.25 VB is equal to 2. Let's call it equation number 1. I'll wait for half a minute. You just follow the steps and see to it that you're getting a similar equation. Yeah? Did you get a similar equation?
Yes, sir.
Oh, great. Now, next step is we have to apply the KCL at node B. So, let me use green color. KCL at node B. So, what is KCL at node B? Now, this is tricky. Huh? Tell me which are the incoming currents, which are the outgoing currents. I mean, how do we write this? Outgoing current is I4 and incoming currents are I3 and 5 amperes. Okay, this is 5 amperes. Okay, so I4 is equal to I3 plus 5. This should be clear. If this is clear, then the numerical is over. Now, what is I4 given by? VB upon 2. What is I3 given by? VA minus VB upon 4. Remember, the direction will remain same. So it's pointing from, starting from VA pointing towards B. So it's VA minus VB plus 5. If we have written this correctly, then the numerical is over if your calculations are strong. Okay, so we can simplify this further. 1 upon, that is 0.5 VB is equal to 1 upon 4 is 0.25 VA minus 0.25 VB plus 5. So you can rearrange the terms. Okay, so finally what you will get, if I take on the left hand side everything on the right hand side, let's say 0.25 VA, and this becomes over here. So what you will get, minus 0.75 VB is equal to minus 5, right? Please cross check this. Now solve this simultaneously in your calculator. So solve 1 and 2 together. It will give you one value of VA and one value of VB. That will help you find the value of current. Now I'll give you half a minute to let me know the answer. Check your equations and put the equations properly.
5.5 and 8.5.
Yes, that's correct. Very good. So that's answer is 5.5 volt and 8.5 volt. I hope everyone is getting the same answer. All right. Anyone else can confirm? Got similar answers? Okay, so please cross check your answers. Now, what we
Yes,
need.
it's
Okay, okay, fine, good. But what we need to find out, current flowing through 4 ohm, that is I3, right? What is I3 given by? VA minus VB upon 4 ohms. So I of 4 ohms will be VA minus VB upon 4. So 5.5 minus 8.5 upon 4. That will be, I guess,
minus 0.75.
minus 0.75 amperes. What is the meaning of minus? That our assumed direction of current is wrong. It should be from B to A. Okay, that's the only meaning of it. Rest it's fine. Are you understanding? What I mean is,
Yes, sir.
this direction is like this. If I want to write it positive, I have to show the direction this way. I hope this is clear. Okay. If they ask you this question in the exam, mostly it will come for 10 marks. Okay. And for 10 marks, mostly 15 to 20 minutes are sufficient. Max 20 minutes, but not more than that. Okay. 15 minutes are sufficient. And we have solved it within around 10 minutes time, this numerical. Okay, let's move on to the next one. In exam you don't get time, right? So we have to keep on moving ahead. That is question number, let's read the next question, 2b. Okay, 2b is related to AC again, so we have to read it thoroughly. So 2b we will be solving now. Two coils are connected in series across a 200 volt 50 hertz AC supply. Okay, the coil means it will have a resistance and it will have a reactance. Either it will be a inductive reactance or capacitive, it we don't know. The power input to the circuit is 2 kilowatt and 1.1 5 k VAR. Okay, if the resistance and the reactance of the first coil are 5 ohm and 8 ohm, calculate the resistance and the reactance of the second coil. Alright. Calculate the active and the reactive power for both the coils individually. So first of all, I hope you all have started studying about AC circuits. So let's break down this question into the separate parts and understand. I hope you all have some background of AC. You all have started studying it. Okay. So let's pictorially depict what they are asking for. Okay. There are two coils in a series. So coil means it will have a resistance and it will have a inductance. They are saying there are two coils like this. Okay, they are connected across a AC supply. So here is my AC supply. This is 200 volt 50 hertz AC supply. They are saying the value of this, let me call it as R1 and let me call it as L1, or they are calling it reactance, right? So let's call it that way. What is the reactance of an inductor written as XL1? Okay, reactance unit is ohms. Do not get confused with Henry. L1 is in Henry, but they are talking about reactance. So this is coil number 1. This is coil number 1. Okay, this is given to you. The values of R is how much? 5 ohm. This is R is 5 ohm, and the value of XL1 is how much? 8 ohm. So this value is 8 ohm given to you. They are asking us to find out the values of R2 and reactance, that is XL2. So this is your coil number 2. I hope the picture is clear to you. They are asking us to find out R2 and XL2. So this is your coil 2. This much is clear to you, everyone? Yes or no?
Yes, sir.
If there is a voltage, let's call that voltage as V, and let's call the current as I. Okay. Now, can you tell me, here they have written there, the power input to the circuit is 2 kilowatt. So what is 2 kilowatt? Can you tell me what is 2 kilowatt? Active power. That means 2 into 10 is to 3 watts. What is 1.1 kVAR? Whose unit is VAR? Reactive power.
Reactive power.
Yes, reactive power unit is VAR, and that is written as 1.15 into 10 raised to 3 VAR. This is very, very important to understand. This is active power, and this is reactive power. And do you know the formula of them? Active power का formula? VI,
VI cos phi.
yes, and reactive power sin phi. That's it. VI sin phi is the active reactive power. Anyways, this will be helpful to us. Just wait. Okay. Can we start now? This much is clear to you. The story is clear to you. What we need to find out, and also we need to find out active and reactive power for both the coils individually. Huh? So basically, let us call this P1. I mean, we have to find out what. Let us write it down. We have to find out R2. We have to find out XL2. Then let us call coil 1 as P1, active power. This is total power, total reactive and active power. So you have to find out active power for coil 1. Then we have to find out reactive power for, let us see, huh, active power and reactive power for both the coils. Yeah. So you have to find out P1, Q1, and then we have to find out for coil 2 also, P2, Q2. Is this thing clear to you, everyone? Yeah? Hello? The picture is
Yes,
clear
sir.
to you? Okay, fine. First of all, um, by Ohm's law, we know, let us start. See, what do we know by Ohm's law? V is equal to, in a AC circuit, I into Z. Okay? If I write in vector form, it is like this. V is equal to I into R, nahi, I into Z. So is the Z known to us? Yes, this is Z1. Let us call this as Z1. Let us call this as Z2. What is Z total given by? Total Z is given by Z1 plus Z2. Is this clear up till now? What I've written over here? Okay.
Yes.
So, also, for finding out the current, what is given to you? Power, right? What is the power formula given by? V into I into cos phi. So, out of this, how many unknown quantities are there? Is this known to you? Yes. Is this known to you? Yes. Is V known to I known to you? No. Is cos phi known to you? No. So either we have to find current or we have to find cos phi. One of them we have to find and we can get the other. Did you understand? Now, how can we use this information? Any ideas, anyone? Can we do one thing? Can we say tan phi is given by Q by P? Yes or no? We can divide this formulas, na? Vi sin phi divided by Vi cos phi. Correct? Yes or no? We can do this, right?
Yes, sir.
It's 1.15 into 10 raised to 3 divided by 2 into 10 raised to 3. So how much is that? 0.575. So you have to do it very patiently. Now you have to calculate phi. So phi will be tan inverse of this number, 0.757. So let me know the answer. We have to be quick a little because we have to solve it in time. Phi is tan inverse of 0.575. How much is the answer of phi? Is it 29.89?
29.89.
Yeah, that is correct. Now, in this equation, we'll come back to this now. Can we write I is equal to P upon V cos phi from here only? What is P given by? 2 into 10 raised to 3. What is V? V is 200 given to you, and cos of 29.89. So this will give you the value of current flowing in the circuit. Can you let me know?
11.534.
Yeah, that's correct. 11.53. Okay. So what did we do? We know the value of V, we know the value of I. Can we calculate the value of Z? Yes. What will be Z given by V upon I? Is it not? So Z total will be given by V upon I. That will be 200 divided by 11.53. That will come out to be 17.35 ohms. Magnitude form, huh? Magnitude form. Okay. Do you know rectangular and polar coordinates? Yes or no?
Yes.
Okay. In rectangular, if polar coordinates, if I want to write z bar, what will be the magnitude? 17.35. Correct? And what will be the angle? This is phi, na? Okay. So this is your polar coordinate or polar form. I want to convert into rectangular form. I can do with the help of calculator. So in your calculator, you can type REC, I think RECT or REC bracket, you can type this 17.35 comma 29.29. So this you do it in the calculator. What answer do you get? How much? 15.04 plus J 8.65. Just cross check. Ohms. Yes or no?
Yes.
Okay. Remember this is total Z. Remember this is total Z, but total Z is Z1 plus Z2, impedance of coil 1 and impedance of coil 2. Whereas Z1, can you write Z1 in rectangular form over here? Z1 is written as R1 plus J XL1. Z2 is written as R2 plus J XL2. Okay. So we can add them together or subtract them when they are in rectangular form. Alright. So this is total Z. Okay, this is total Z. And I mean, I want to calculate how much. Acha, what is Z1 now from here? Z1 is given to you, na, R1 plus J XL1. It is given to you, na, R1. R1 is 5 ohm, XL1 is 8 ohm. So 5 plus J8. Okay. And now next step will be Z2. How do we calculate Z2? See, we know Z is Z1 plus Z2. So what will be Z2? Z minus Z1. Total minus Z1. So 15.04 plus J 8.65 minus 5 plus J 8. Okay, you can solve it. So let me know the answer.
10.04 plus 0.65 J.
In ohms. Okay, now this is in the standard form, right? Z2 is R2 plus J XL2. So can you tell me what is R2 from here and how much is XL2? 0.65 ohms. That's the answer. That is what they want. They wanted R2 and XL2. We have found out that. Okay. So this is the answer. I hope it is clear to you. Yes. Now they are asking. Next is active power consumed in the in both the coils. So active power consumed in coil 1 will be P1 and it is given by, no need to find out Vi cos phi again. You can write it as, another formula is I square into R1. Acha, this is okay. What is the reactive power? I square into I square X. XL1 is the reactive power in coil 1. Similarly, what is active power in coil 2? I square R2. And what is reactive power in coil 2? I square XL2. So please calculate all of them. What is the current given by 11.53 square? R1 is 5. 11.53 into 8. 11.53. R2 is 10.04. And finally XL2, just now we have calculated it to be 11.53 square into 0.65. So these are all the answers. 664.7, this is 1063.53, this will be 1334.73, and this will be 86.412. Please cross check if you get these answers. Remember, important is unit. Active power unit is what? What is the reactive power unit? VAR. If you write the wrong unit, your correct answer will also become wrong. So be very careful by writing the unit. Okay. So this is the active and the reactive power consumed in both the coils individually. Alright. Please note it down if you haven't noted. Just give me a minute, I'll come in a minute. Have you all completed by now? Up till here? Can we move on to the next one? Hello? Hello,
Done, sir.
students? Okay, great. Um, Next is question number 2C. This transformer topic I am going to record the lectures and share it with you all. Still, it will take some time. Principle of working of a single phase transformer and derive the EMF equation for the same. Alright. So let me just add, this is a theoretical question. Question number 2C. So we have a single phase transformer. Remember, transformer topic is pretty easy. It's not so hard at all. You have to work for it, of course. So here, how do we get the marks is as follows. Principle of operation, and derivation of EMF equation. EMF equation derivation. So if it is a 5 marks question, we'll give equal weightage to both. Let's say this is 2 marks, let's say, and this is 3 marks. If this is 5 marks question total. Alright. Above one is 10 marks question. This is 10 marks question. The one which we have solved. Okay. That's why it took some time. Alright. This will come for 5 marks. The single phase, if it comes for single phase transformer, principle of operation along with the transformer symbol, and EMF equation derivation. Is it fine? Can we move on to the next one? Yeah.
Yes.
Okay. So let's be a little quick now because we have already 1 hour 40 minutes. Around 100 minutes are over. Now I'll be a little quick. Okay. So let's go to question number 3A. This one. A balanced three-phase load consists of three coils, each of resistance 4 ohm and inductance 0.01 Henry. It is connected to a 440 volt 50 hertz three-phase supply. So it's a related to AC circuit, three-phase circuit. Find the total power consumed when the load is connected in star and the total reactive power consumed when the load is connected in delta. So we have to see whether the load is star or delta, and it's pretty straightforward numerical. If you have solved three phase is actually very simple. It's a hype that it's a difficult topic, but once you get to know it, it's pretty simple. So let's try to answer this question quickly. So what they have given is they have given a three phase load, okay, and we'll first concentrate on star connection. I mean, you can write it down along with me. So we have a coil. Coil means resistor and inductor. Okay. Similarly, you can. This is star connected network. Looks like this. In exam, no need to draw it. Just for the sake of understanding, I am drawing it over here. We have R, Y, B. Okay, and this is a coil, right? So coil is represented as R and Z. Resistance, coil number 1, coil number, this is a three phase network, no? That's why we have a star connected load. So this is your coil. Each of them will have a Z, I mean, we are calling it Z phase. Impedance of the coil is same. Every coil is same. It's a balanced load, right? and we have a three-phase supply over here. So we have a three-phase supply of 440 volt, 50 hertz. Okay, the current is flowing, the load current, we know in a star connected load the load current and the phase current are the same. Okay, so this is your this line current and line current and the phase current is the same. This is my line voltage VL, and we have to find the active power consumed in a star network and reactive power consumed in the delta network. All right, so what are they asking you to find out? They're asking you to find P, active power, and in a three phase network it is given by the formula root 3 VL IL, anyone, cos phi. So basically we need to find VL. VL is actually given to you. um, VL is known to you, this is not known to us, and cos phi is not known to us, and we have to find out this. So two unknowns are there, we'll find IL and cos phi, and then we can easily find the value of active power consumed. So this is the active power. Is the picture clear to you? What is given, what is to be find out? Yes or no?
Yes.
Okay, so now here the resistance of each coil. So let's say your Z phase is actually R plus J XL. Now what's the value of R given to you? R is given as 4 ohm plus J XL. XL, how do you calculate? 2 pi FL. So 2 pi, F is 50, L is how much? Inductance is given as 0.02. Okay, calculate this number. This is 100 pi into 0.02, so this is 6.28 ohms. So we can write Z phase as the impedance of each coil is 4 plus J 6.28 ohms. I hope it is clear. This is impedance of each coil. There are 3 coils, so impedance of all the coils are same. Now this is in you know rectangular form converted into polar form. So you will type in the calculator polar 4 comma 6.28. What you will get over here? Can anyone tell me? 7.45 at angle 57.51. Are you all getting this? Please cross check. Let me know yes or no. And this is in the standard form Z phase angle phi. Let me know if you are getting this answer.
Yes.
Okay, so that means your phase angle phi is 57.51. So that's great news. If you know phi, you can find out cos phi, and then you can find the current also as well. IL also will find out very soon. So we can find out active power very soon. So phi is known to us. Next, um, and also Z phase is known to us. I mean, here only I can write 7.45 ohms. All right. Next is um, we know V is equal to I into this thing. So now let us find phase voltage. Phase voltage is VL upon root 3. VL is given as 440. See, the numerical in the numerical is given as 440. That's the line voltage which is given, divided by root 3 volt. Okay. What is I phase? It's V phase divided by Z phase. V phase is 440 divided by root 3. How much is Z phase? 7.45. So if you put it in the calculator, you will get I phase as how much? 34.1 amperes. Alright. And in a three phase star connected load, or in a system, your line voltage is equal to your phase voltage. That is 34.1 ampere. Alright. So once we know the value of IL, we can calculate the active power P. P in three phase is given by three phase star. Star or delta formula is same. VL IL cos phi. So it will be root 3. VL is 440. IL just now we have found out 34.1. Cos phi is cos of 57.51 degrees. Alright. So what is the power in three phase now? It will come out to be closer to 13.96 kilowatt. You can please find it out. I'll give you 1 minute's time to calculate this much. I hope you are getting the answers. Yeah?
Done.
Okay, great. Now second case, they are saying ki calculate the reactive power when the load is connected in delta. Now just for the representation sake, I am drawing the delta network. No need to draw in exam again. Okay, so just for the representation sake, delta connection. Okay, so a delta connection looks something like this. You have a RL, I mean the coil is there already, but now we are connecting in delta. So Z phase will be same, huh? Impedance of coil will be same as that of star. What will change? I'll tell you. So this is your R, this is your Y, and this is your B, R Y B, and these are the three coils. Okay. All right. I hope this is clear. And this is the line current, line voltage. Okay, and the impedance of each coil is Z phase, ZPH, and here it is connected to a, sorry, three phase 440 volt 50 hertz system. Okay, these are the three coils, RL RL RL. Okay, so this is three phase delta connected balance load. What do you mean by balance load? Balance mean all the three coils are identical in value. So from the previous numerical, we have found out the value of Z phase. How much is that? 7.45 angle 57.51, right? So we have find out Z phase as 7.45 ohms, and we found out angle as 57.51 degrees. So from previous numerical, this remains the same. Okay. So what will be different is, again, here also what do we need to find out? We need to find out Q is the reactive power. Anyone knows the formula of Q? Root 3 VL IL sin phi. Correct. So VL is known to you. VL is known to you. It's 440. IL is not known to you. Sin phi you can calculate because you have phi value. So you have to calculate IL. Okay. So let's begin. So in a delta, this is what we need to find out. Okay. In a delta connection, your line voltage is equal to phase voltage. This you remember. Okay. In a star connection, line current was equal to phase current, but here line current is equal to phase current. And what will be I phase given by over here in this case? V phase divided by Z phase. So here V phase is 440, Z phase we have calculated 7.45. It will come out to be 59.06 ampere. Please calculate this number, cross check it. So in a delta connected load, line current is root 3 times phase current. This we can check it out. It's a standard formula. Root 3 times 59 point. By the way, did you get 59.06 amperes? Yes. This is line current. This is phase current. Okay. And the reactive power will be given by root 3 VL IL sin phi. That will be root 3 into VL. It's actually 440 into IL into sine of phi is around 57.51. So if you put it in a calculator, Q will be around 65.75. Unit is kVAR. kVAR. You can easily cross check it with your own calculator. And this is the reactive power. And this is three phase network. Reactive power consumed in a three phase delta connected load. Okay. Are you calculating? Till where have you reached?
Sir, done.
Great. Now we have a little bit of relief. Some questions and theoretical questions now coming up. Okay. Next is 3B. It's an open circuit test conducted on a single phase transformer. This is not there in the syllabus. Current syllabus, it's not there. Okay. Next will be draw phase circuit diagram of half wave rectifier with capacitor filter. This is done. I am not covering it. This has been covered before. And with the help of neat diagram, explain input characteristics of NPN transistor. This is also been covered. Okay. So let me just write it down over here. If someone is referring the paper, they should know what is in Transformer open circuit and short circuit test is not there. So question number 3B, not in current syllabus. This is May 2014 paper. So this was the old syllabus. 3C, we have a half wave rectifier with C filter. Again, circuit diagram, input output waveforms are asked. Okay, so there are standard marks for it. So circuit input output waveforms. So marks are, let's say this is given as around uh, 2 and this is 3. Alright, if it is a 5 marks question. Then question number 3D, explain with the help of circuit diagram input characteristics of NPN transistor in a common emitter mode. So NPN transistor, this has been discussed before. NPN transistor in common emitter mode. Okay, so again the split up of marks will be the circuit input characteristics and the explanation of the same. Okay, so this will be around 1 mark, this is 2 and this is 3. I mean, if it is a 5 marks question, then explanation also 2 marks. So I'm giving you the split up of marks if it is asked in the exam. Alright, this is about the theory question. Now let's move on. Now we have to little bit dress it up. Last 1 hour left. We started at around 4 o'clock. It's 2 hours past. It's 6 o'clock now. And by now you should, reach question number 4. I mean, we spend a lot of time in explaining you the three-phase phasor, but it's fine. Let me know whenever you require a break. You require a break now, or shall I continue?
Continue.
Okay, fine. I'll definitely do that. Yeah. So, next is using source, question number 4A. Again, it's a DC network theorem. Using source transformation, find the current flowing through 10 ohm resistance. So, this is the circuit given to you. So, note down the circuit. Note it down, the circuit diagram. So, you need to find current flowing through 10 ohm resistance only using source transformation. Okay, so let me redraw the circuit over here. This is how much? 10 amperes. This is 10 ohm resistance. 2, 5. For DC networks, DC circuits, you have to always draw the circuit again, mostly. Okay, this is 3 ohms actually. So I hope you are drawing the circuit along. This is 5 ohm. This is 10 volt, 1 volt, 1 ohm, and 30 volt. And what we need to find out, current flowing through 10 ohm resistance. We cannot use any network theorems. We have to solve it using Only source transformation, meaning current source into voltage source into current source, like this. Alright, and it's a 10 marks numerical. We should not spend more than 10 minutes in it. Can we start? Yeah? You'll have drawn the diagram?
Yes.
Okay, great. So now, in the first case, can you see this 10 volt and 30 volt are in series, right? So what will be the total network over here? I mean, how will I draw it again? This is 10 ampere, 10 ohm. Whatever, remember one thing, whichever current we want to find out, don't transform that. Okay? So current flowing through this is, do not transform. 3 ohm. Can we say that we can add them together? That will be around 30 volt minus 10 volt. This is 20, correct? If you go from here, it will be minus 10 plus 30. Yes or no? It will be how much? Plus 20, right? This is plus 20, 1 ohm. Now what do? We convert this voltage source and series resistance into a parallel current source. Alright, so let's do that. How much is that? How much is the current source value? Anyone can tell me? 20 volt divided by 1 ohm, that is 20 amperes. And draw the remaining circuit quickly. Alright, 10 ampere, 10 ohm, 3 ohm, 5 ohm. Yes or no? Agree?
Yes.
So this 5 and 1 are in parallel. 5 ohm parallel to 1 ohm. That will be 5 into 1 upon 5 plus 1. That will be 0.83 ohm. 5 ohm parallel to 1 ohm. Okay, so let me redraw the network now. This is from here. 0.83 ohms, and we have a current source 20 amperes. This is 3 ohm, this is 10 ohm, and this is 10 ampere. Now again, this parallel resistance, these two will be converted into a voltage source, and the value of the voltage source will be 20 into 0.83. That will be 16.66 volt, correct? The value of the resistance will be same, and the rest of the network you connect it. Alright, so this is what we get, 3 ohm. Okay, so as we know, this 3 and this 0.83 will be together, and we can call it as 3.83 ohm. So instead of drawing it again, I'm directly converting this series resistance and this voltage source as a current source in parallel. All right. I hope you will follow up. So this is the resistance 3.83. This is the current source. What's the value of the current source? 16.66 divided by 3.83. That will come out to be 4.346 ampere. Remember, don't do anything to 10 ohm resistance, because that is the resistance we want to find the current through. This is 10 ampere. So far clear? Yeah. Now what will happen? 10 ampere and 4.346 ampere current source will add up, okay, and will become how much? 14.346 ampere current source. Also 10 ohm resistance will be in parallel to 3.83 ohm resistance. How much is that? I mean, sorry, we cannot do it in parallel. Yeah, as I told you, sorry. So what it will become now? You have, this is what you will get: a current source of value 14.346 ampere. This is 10 ohm and this is 3.83 ohm. Now you can tell me how to find the current now. Now at least you can tell me. So by current division rule. What does the current division rule says? If you want to find the value of current through that branch of resistance, you have to you have to write other branch resistance, that is 3.83 into current source value 14.346 divided by total resistance 3.83 plus 10. I hope it is clear to you. And this will come out to be 3.975 amperes. Please cross check the answer. Okay, so simply by using a source transformation we have solved a value, value for the current asked. Yes. Let me know when it's completed.
Done.
Is the answer matching?
Yes.
Okay, fine, great. So we are going at good speed now. In 10 minutes we have completed a numerical of you know a higher value. Now we are going fast. Now question number B, 5B, 4B. Find the RMS value for the given waveform. Okay, this is the waveform given. Similar type of numerical we have solved in the class, but we'll address this nevertheless. I'll only show you the technique. Just to save time, I'll save on the calculations. You can find out the values, I'll on your own little bit. Question number 4B, we have to find the RMS value, that is VRMS of this waveform. So this waveform is given like this. You first of all draw a dotted line, and it's going to be repetitive, that's why they have not drawn another cycle. Here it is at the center, pi by 2, and the waveform is looking like this. Okay, let me erase this. Okay, this value is 0.866 Vm. This higher value is Vm. This is voltage. What it means is the waveform in general looks like this. Okay, this is following sinusoidal nature from here, uh, from 0 to over here, and from here to over here, pi by 2 to pi. So basically we don't know this period, we don't know how much is this, right? Let's call it phi 1. We don't know that value, right? And they have given it sinusoidal nature over here and here, correct? So how do we find it now? Anyone knows? So let's say at theta equal to phi 1, what is the value given? 0.866 Vm is equal to how much? It's equal to Vm sine phi 1 or sine omega t or sine theta, right? So we can equate the two. Vm gets cancelled, and what do we get now? What is phi 1? Sine inverse of 0.866. How much is sine inverse of 0.866? I think 60 degrees, right? Just cross check. And convert it into radians. So how to convert into radians? Multiplied by pi by 180. So that will be pi by 3 radians. So this value is actually pi by 3. Now we have to write the equation of V. So V is equal to Vm sine theta, where theta goes from 0 to pi by 3. So from 0 to pi by 3, V is Vm sin omega t, it's sinusoidal nature. Then it becomes a constant value from pi by 3 to pi by 2. I hope this is clear. And then V is equal to again becomes Vm sin omega t from pi by 2 to pi. So from this discussion we came to know that the time period is pi. Okay. And do you know the formula for Vrms? So Vrms square will be 1 upon t 0 to t v square theta d theta. This much is clear to you, everyone? Hello.
Yes.
Okay. Now it's the matter of substituting in the formula. So we can write Vrms square, of course. Instead of period t, we'll write 1 upon pi 0 to pi v square theta d theta. Now we'll write it as 1 upon pi. 0 to pi will be split up into 3 intervals. So first interval will be 0 to pi by 3. V square theta is how much over here? Vm sin theta the whole square. Okay, d theta. Then we have pi by 3 to pi by 2, 0.866 Vm square. Then we have d theta. Okay, then we have pi by 2 to pi Vm sin theta square d theta, the whole bracket, pi. So that is what we have to solve. Okay, now I'm leaving the solving part up to you all. I mean, next step will be what? What is sine square theta? 1 minus cos 2 theta by 2. Correct? Here also you apply. Here also you apply the same thing over here. And then you integrate it. It will be theta by 2 sine. I mean, again you will get sine 2 theta by 2, that is 4. And similarly you can solve this further. It's a calculation, simple calculations are there. It will take some time for us. That's why I'm directly giving you the answer for this now. Is it okay if I directly give you the answer? You all can solve it,
Yes.
save some time. Okay. So VRMS, you can sort it out, solve it out later. 0.687 Vm. That is the answer. Okay. So please solve it patiently. We'll rather solve some more numericals, new numericals. This is known to you. Just the substitution of these values over here and integral limits. You'll get the answer. Remember, whenever sine comes and whenever you're substituting pi by 3, please convert it back into degrees. Okay? Because when you calculate anything, it should be in degrees. Is this fine? Can we move on to the next one now? Quickly.
Yes.
Okay. Next is simple. It's quite simple. Okay. So let's see what is the next one now. Okay, 2 wattmeter. Great. It's the simplest one. 2 wattmeters are used to measure power in a three-phase balanced star-connected load using 2 wattmeter method. So this is the simpler one. This is the ones which we have to complete in the exam. Solve. It's like these are like very easy. And again, there is another one. D part. With the help of neat circuit diagram, input output waveform, explain the working of full wave center type rectifier. For y'all also you can solve it easily. Anyways, going back to C. Two wattmeters are used to measure power using 2 wattmeter method. The reading of the 2 wattmeter are 8 kilowatt and 4 kilowatt respectively. Calculate the total power consumed by the three phase load and the power factor. The simplest numerical in the entire syllabus. I'll show you how. Okay. So this is question number 4C. Okay. So it's the question for 2 wattmeter method. Only two formulas are there, nothing else in this. Two, three formulas are there in this. Now, two wattmeter readings now. The higher reading, write it as W1. What is the higher reading? 8 kilowatt. Lower reading, write it as W2. The wattmeter reading, 4 kilowatt. And what you need to find out, total power consumed and power factor. See, it's organically very simple numerical. I'll show you how. Solution. What is the as per the 2 wattmeter method, the power consumed is given by W1 plus W2. Just we have to add them together. 4 kilowatt plus 8 kilowatt, that will be 12 kilowatt. You will say it is that easy. Yes, it is that easy. Next, we have to find the power factor. What is power factor? Cos phi. So you have to first find phi. So if you check the numericals of 2 wattmeter method, there is this one formula given, tan inverse of root 3 higher value of wattmeter reading, that is W1 minus W2 divided by W1 plus W2. That's it. Only one formula you have to remember. That will be tan inverse of root 3. W1 minus W2 will be 8 minus 4, that will be 4 kilowatt. And below 8 plus 4 will be 12 kilowatt. Pretty easy calculation is there. So this will be 3, root 3 by 3. Okay. So what is the value now for phi?
5/6.
In terms of degrees, yeah, 5 by 6. In terms of degrees, it will
30
be,
degree.
yes, 30 degree. And then next step will be, you see the length of numerical and the amount of marks given to it. Power factor is cos phi. cos of 30 degree, which is 0.866 lagging, because the angle is positive. If the angle is negative, it will be leading. Is this clear to you? Very easy numerical, right? We didn't even take more than 3 minutes to solve this. Yeah?
Done.
Yes, yes. I am covering the next part now. Next is question number 4D. Yeah, we have covered this out, but still in writing. We have to draw full wave center tap rectifier. So here they have asked the working also. It's a 10 marks numerical. So first of all the circuit diagram, then the working, then the input output waveforms. Okay, so working circuit diagram we can give 2 marks, working will be around 5 marks, and this is 3 marks. So that's how you get your total 10 marks in this theory question. It's actually D, yeah, 4D, full wave center tap rectifier. We are almost coming to the end now. Okay, question number 5. Actually we are solving each and every numerical, right? That's why it's taking some time, don't worry. Question number 5. For the given network, find the value of RL and find the maximum power absorbed by RL. Okay, so it's a straightforward maximum power transfer theorem you have to apply. Okay, shall we start?
Yes.
Yeah, okay. So question number 5A, we need to find RL, and once we find the value of RL, we have to find the maximum power. So let's be a little quick in this. uh, 4 ohms, 5 ohms, 8 ohms, 1 ohm, and then this is what is the numerical given to you, 10 volt, and this is how much, 2 ohms. Okay, this we can call it as A and B. So let's concentrate over here. So basically what is the Pmax formula? Do you remember Pmax formula for maximum power transfer theorem?
VTH square upon 4 RTH.
Yes, VTH square upon 4 RTH. In short, we have to find RTH and VTH, correct? Once we know RTH, VTH, we can say RTH is equal to RL, and that will be the value of RL. Okay? Because in maximum power transfer theorem, when RL is equal to RTH, maximum power is transferred from the source to the load. And Pmax formula may we require VTH also. So in short, we have to calculate RTH and VTH. Okay. So now for calculation of VTH, what do we do? How do we calculate RTH? RTH. Help me out quickly. We remove the load, right? Yes or no?
Yes.
And we deactivate all the sources. We make this open, A and B, and we deactivate the sources. That means this voltage source will be acted by a short circuit. Now here we have to find the value of RAB or RTH. This is 1 ohm, 8 ohm, and this is 2 ohm. Okay, let's concentrate over here. How do you solve for the? Oh, this 2 ohm, can I take it inside? Instead of connecting it outside, can I take it inside? Yes, I can take it inside. Now, does it look familiar? Can we apply any delta star transformation? Yes or no? See,
Yeah.
this is delta. We can connect it to star. Let me call it R1, R2, R3. Now, here this is what? Delta to star. Sorry, I should not write short form. Delta to star transformation. Can you tell me what will be the value of R1? R1 will be 4 into 5 divided by total resistance, 4 plus 2 plus 5. 4 plus 2 plus 5. Okay. Similarly, what will be R2? 4 into 2. Are you understanding what I am doing? 4 into 2 divided by total, 4 plus 2 plus 5. What will be R3? 5 into 2 divided by 4 plus 2 plus 5. So calculate this much. This will be 20 upon 11. This will be 8 upon 11. This will be 10 upon 11. How much is this? 1.818 ohms. This is 0.727 ohms. This will be 0.91 ohms. I hope you are following. And then draw the network again. Don't draw 5 ohm, 2 ohm and 4 ohm again. Resistance value. This is 1.82, let's say. This is 0.91 and this is 0.727 ohm. And draw the remaining part of the network. And this is point B. This is 1 ohm. This is 8 ohm. I hope you are following this. Now here this can be simplified further. These two are in are in series. This is 1.727 ohms. This is 8.91 ohms. This is 1.82 ohms. This is A. So now we have to determine the parallel combination. 1.727 ohms parallel to 8.91 ohms. How much is that? You have to quickly calculate. That comes out to be 1.448 ohms. Okay. B 1.448 ohms, 1.82 ohms. Those are in series, right? So RAB is equal to RTH is equal to 1.82 ohms plus 1.448 ohms. That will be 3.27 ohms. That is the answer. I'll give you half a minute to complete this much. I hope you are getting the similar answers.
Yes.
Okay, already got. Great. Then here we can write a statement that maximum power will be transferred from source to the load when RL is equal to RTH. So RL will be equal to 3.27 ohms. You have calculated first part. See, in exam sometimes you don't have time, right? So instead of solving the entire numerical, you can at least calculate up till here. Up till here you will get 5 marks if it is a 10 marks numerical. Okay, don't try to solve everything. But whatever you know, do that confidently. Is this clear to you? Can we move ahead? Straightforward. Yes? Okay.
Yes.
Okay. Yeah. Now we have to calculate VTH. For VTH again remove the load and draw the circuit diagram. So we might have to, in DC networks, drawing the circuit diagram again and again takes some time. So that's why the other numericals you can be fast. Formula based numericals. This is entirely concept based, so it will take some time. This is how much? 1 ohm. Okay, so we have to find VTH, meaning VAB, or we can call it VAB. There are several methods to do it. I'll tell you the shortest method. Let us call the current over here as I1. Let us call the current flowing over here as I2. And let us find this total current as I. Okay. Now listen what I'm saying now. Now, if for the sake of conversion, if I convert this, 4 ohm and 5 ohm are in series. If I want to convert this is 9 ohm, this is also 9 ohm. Okay, and this is connected like this. This is the scenario, right? This is I, this is I1, this is I2. This is 2 ohm and this is 10 volt. 9 ohm and 9 ohm in parallel becomes 4.5. Half, na? Same resistance become half. This is 2 and this is how much? 10 volt. If anyone wants to calculate current I, how much is I over here? 10 volt divided by 2 plus 4.5, correct? So how much will be I here? Can anyone calculate? 1.538 amperes. Now from here, can you calculate I1 and I2? Yes. How much is I1 by current division rule? 9 other resistance into the current I, right? 1.538 divided by total 9 plus 9. Don't you think I2 also will be same? 9 into, because both the resistance are same, so equal current flows through them. So this will come out to be 0.769 amperes. If you have a doubt, you can ask now, or else I shall proceed. Do you have a doubt? How do we got this currents I1 and I2? By current division rule. Hello.
Proceed.
Yeah, it's, yeah, okay, fine. Now I want to find VAB. So see, I'm marking a current branch over here from year to year. I'm redrawing it in different color. Okay, here there is a branch B. This is 1 ohm. This is how much? 4 ohm. This is A. The current which is flowing over here is I1. The current which is flowing over here is I2. Now, if I go like this, sorry, if I go like this, I mean, let me save this file once. We calculate VAB if you all are comfortable with it. If I go like this in this direction, how will I write? I mean, what is the value of VAB then? Anyone? Which is same as your VTH. 1 ohm, see it's opposite direction current, right? So that will be positive 1 into I2, and it's in the same direction, that will be negative I1 into 4. So that is what you will get. So 1 into I2 will be 0.769 minus 4 into 0.769. So VTH will be minus 2.3 volt. This is what you will get. Okay, and then finally your maximum power will be VTH square upon 4 RTH. So minus 2.3 square, that will become plus 4 into RTH is how much? 3.27. So maximum power will come out to be 0.41 watt. Please cross check your answers. Yes?
Yes, sir.
Okay. Yeah, it's a paper is loading a bit. Our 2 hours and 40 minutes are over because we are solving on all the numericals. That's why it's taking some time. Yeah. 5B is we have solved this. Huh. The voltage and current in the circuit are given by E equal to 100 sine omega t plus 30 degree, I equal to 50 sine omega t plus 60 degree. Determine the impedance of the circuit. Okay, simple. So impedance is E means we can write it in the terms of V also, V by I. So that will directly give you impedance. Assuming the circuit contains two elements in series, find the resistance, reactance and the power factor of the circuit. So we have to assume that there are two elements connected in series. Okay, probably it might be reactance because it can be capacitive or inductive. All right. So let's draw a mental picture and try to solve it. We are almost at the end. Will require around 20 to 30 minutes more, and we are done with a 3 hours paper. Okay. Yeah. Let me just minimize this. Yeah. And let me try to frame what is being asked to you in terms of diagram. All right. Okay. Question number 5B. So E is 100. E is written as a voltage over here. It's also called as EMF voltage. This is 30 degree, right? Sorry, I've written as uh, this should be 30 degree, and current is how much? 50 sine omega t plus 60 degree. And what are they asking us to find? Z, then R value, reactance value X, either L or C we will find out, and the power factor. So these all things we have to find out. And they are saying there are two elements in series, so we don't know, right? I am drawing it a box. there are two elements in series. One of them is a resistor, other is the reactance is given to you. So this is E given to you, this is I, this is 100 volt. uh, I mean the peak value is 100, so 100 root 2 sine value, because we write the RMS value, right? So let me write E only over here, no problem at all. E is my voltage, right? And these are the two elements in series. So their impedance will be what? This is impedance. So what will be the impedance of the circuit? Capital E upon capital I in polar form. I mean in the vector form. Okay, fine. So let's start. So let me write the capital value of here. This is standard form, huh? This is standard form. This is not a polar or rectangular. This is standard form. So this value is the peak value. So RMS value will be 100 root 2. Okay, and angle we can write it as 30. This is phi, right? This is 30. So 100 root 2 is how much? 70.71 angle 30 degree. This is my voltage. What about my current? 50. Again it's a peak value, so 50 by root 2 becomes RMS, angle 60 degree. So this will be 35.36 angle 60 degree volt. So what will be Z? As I told you already, Z will be E bar upon I bar. We can divide polar, this is in the polar form now. So 70.71 divided by 35.3, this will become half exactly, 30 and 60. So if you divide angle, it will go up and subtract. So this will become 2 angle 30 minus 60, that will be minus 30. Okay. Now we have to convert this into, this is polar form, we have to convert this into rectangular form. So in your calculator you can do rec 2 comma minus 30. So what you will get is 1.732 minus J1 ohms. Now if this is minus, we have a standard form. If Z is minus, it is possibly XC. Okay. So from here, what is R? The resistance value is 1.732 ohms and XC value is 1 ohm. That is what they are saying. You know, the value of the circuit elements. So these are the value of the circuit elements. That is what they were asking. And the fourth one is they are asking us power factor. So power factor is cos phi. Now how much is the phi value over here? Minus 30 degree. So cos of negative angle won't make a difference, but cos of 30 degree is 0.66. Since the angle is negative, the power factor is leading power factor. I hope it is clear to you. I know I was a little quick, but we are falling short of time. That is why, and in your paper also, actually, last half an hour your speed increases. You should increase because you have a lot of things to cover. I hope this is clear to you. It's a simple numerical, but a tricky one because it is very simple. So you sometimes doubt whether something is wrong or something is missing. But sometimes the simplest answer is the correct answer. Okay?
Done.
Yeah, great. Okay. So good news is question number 5C is out of context because it's a numerical on transformer and numerical in transformer is not there. So expect a theory question in transformer in the exam, okay? And I will tell at the end the overall, the view of the paper. So remind me, this is 5C, this is not in current syllabus. Yeah, sorry. Not in current syllabus. You don't have numericals from transformer module. Okay. Let's move on to the next one now. Last part, last question. We have to quickly do that also. Yeah, it's loading. The page is loading. It's been open for more than around about 2.5 hours, so it's taking some time. Yeah, the last questions are as follows. First of all, can we come to 6A later? Is that fine? Can I find 6B slightly important because I mean it's related to AC. I want to cover that first. Is it okay?
Yes.
Yeah. So I'll solve 6B first. 6A looks simpler because it's familiar. Superposition theorem we have solved it before, so this can be easily solvable. So we'll solve 6B first. This is the way you need to take a judgment call. Huh? No one is going to, question you or judge you on that key you have not solved the question in order. So this 6A will solve it later, no problem at all. Okay, let me erase it, try to erase it. Yeah, we'll solve 6B first. So what does the 6B says? Okay, it's again loading. Actually, the 6B is very simple. It's like you have to use just three formulas, that's it. Yeah, I'll tell you. A inductive coil having a resistance 20 ohms and inductance of 0.2 Henry is connected in parallel with a 20 microfarad capacitor with a variable frequency and 230 volt supply. The longer the numerical statement, the more simpler it is actually. Find the frequency at which the total current drawn from the supply is in phase with the supply voltage. So whenever the total the frequency is asked is related to resonance, okay, and here R and L are connected in parallel with C, so it's RLC parallel, okay. So this frequency is resonant frequency. So you have to find the current at resonant frequency and impedance of the circuit at resonant frequency. Yeah, this is very simple. I'll tell you how to tackle this kind of numericals. First of all, we'll draw it very quickly. Resistance in series with a inductance, and that is in parallel with a capacitor. So see RLC. Okay, this is 20 ohm. Inductance is zero point 0.2. Yeah, zero point 0.2 Henry, and capacitor value is 20 microfarad. That's it, and it's connected to a AC source. Okay. Yeah, let me save the file first. It's connected to AC source 230 volt. Variable frequency is given to you. Okay, and what are they asking you to find out? At resonance. Okay, at resonance, the total current drawn from the supply is in phase with the supply voltage. That happens at resonance. So this is at parallel resonance because it's a parallel RLC circuit. So parallel resonant condition applies. So all the formulas related to parallel resonance will be asked. So your FR is asked, resonant frequency. Next we have to find ZR, impedance at resonance, and current at resonance. Okay, R represents resonance. So at resonance, at parallel resonance, the frequency formula is given by 1 upon 2 pi. It's a standard formula. Remember in series resonance it was just 1 upon LC, right? But here it is this also, R square upon L square. So this is the formula. Obviously you need to substitute the values to get the answer. So be very patient because it's a very simple numerical. You have to be more patient in it. Zero point 0.2 into 20 microfarad. because here there are 10 raised to minus 6, so chances of mistake are very high. This is 20 square divided by 0.2 square. Okay, so do it very calmly. You will eventually get a proper answer. It's 77.97. If you solve it calmly, you will get the correct answer. Unfortunately, last 10 minutes, last 5 minutes, you are in a hurry, so you might tend to do mistake. Don't do that. Slow down. Do it correctly, whatever you're writing. If you know the formula, there should be no mistake at all. Then, if you find this, impedance at resonance is given by the formula L upon RC, that is 0.2 divided by 20 into 20 into 10 is to minus 6. So this comes out to be 500 ohms. So you can cross check your answer. And finally IR, which is V upon ZR. V is given as 230, ZR is 500. So this comes out to be 0.46 amperes. So straight away, as I told you, just the three formulas are required. That's it. Series, parallel, resonance, AC circuits are important. You need to know the concept, the formula, and when to apply what. And you should have the presence of mind to use the correct to have used the correct formula.
Done.
Okay, great. Done. Yeah. Yeah, hopefully the last numerical, the last this thing is yeah, a theory question. 6C. So with the help of a circuit diagram and a phasor diagram, explain 2 wattmeter method to measure power in a three-phase balanced delta connected load. Now at the start I showed you that technique, right? In a I think in lecture number 41 or 40, that technique was shown to you. So that phasor diagram also draw it similarly. You read that question and answer the question accordingly. Okay. So yeah, let me just write it down to just let me break up of marks. I'll give it to you. 2 wattmeter method, if it comes in the exam, the circuit diagram, then the explanation and the phasor diagram. The circuit diagram should carry around 3 marks, phasor diagram 3, and this should be 4. This is the split up of marks if it is a 10 marks numerical. Okay? Yeah. So yeah, that's it. I'm just writing the marks, but you have to eventually write the answer in the exam. We have solved on mostly all the numericals over here. Only one thing is left. One last numerical is there. You want me to solve this superposition, or you all will manage on your own? I mean, I don't. I
We'll
can.
manage.
Okay, I'll give you the answers. Okay, just write down the answers when you solve it, so that you can cross check it. So find the value of the current flowing through 5 ohm resistance using superposition theorem. 6A. Why I'm not solving is because we have solved similarly for superposition theorem before also. That's why I think it's a similar one. Find the current through 5 ohm resistance using superposition theorem. So superposition theorem, the concept has been clear to you now. Here there are three cases. Case number one, when you consider 5 ampere current source. So 5 ampere current source alone, you will get the answer as current through 5 ohm resistance dash will be 3 point, oh sorry, will be 3.66 ampere and the current is direction is down. When you consider, okay, let me save this file first. Okay, we have 10 volt voltage source, then the current will be given by I double dash, that will be 0.536 ampere, and that current will be above. Okay, the current direction changes over here. And third case, 2 ampere current source alone. When you considered it alone, this answer will be 0.2797 amperes, and that will be down. And the total current will be I phi dash plus I phi double dash I of 5 ohm resistance triple dash, and this will be 3.4037 amperes. All right. Yeah. So this is the answer to the question of 6A. And with this, we have come to the end of the solving the question paper of May 2014. Okay. So now I will take your queries if you have any.